Hi and welcome everyone. In this session, we are going to dive into the basics of regression analysis. We will start by understanding the fundamental concepts and gradually build up to more complex ideas. Let's take a look at what we will cover today. We will begin by exploring the difference between independent and dependent variables. Next, we will define what regression is. After that, we will look at some practical uses of regression. And to make these concepts more clear, we will go through specific examples of how regression is used in different fields. And then before we dive into building models, we need to discuss the assumptions of the error term. These assumptions are essential to make sure that our regression models are valid and reliable. Building on that, we will explore simple linear regression models. And then also we're going to have a look on the multiple linear regression models. Finally, we will summarize the main objective of regression analysis. By understanding the basic concepts of independent and dependent variables. The independent variable, often represented as X, is the one that influences or predicts the dependent variable, which we denote as Y. So we have been familiar with these concepts, since our early school days, probably as early as standard 4 or 5 in our science classes. Back then, we learned that independent variable is similar to the manipulating variable, while the dependent variable is the response. So in simple terms, the dependent variable y is the one that we are trying to predict or estimate, where the independent variable x is actually the predictor, the factor that we think is driving can cause the changes in y. So understanding this relationship is actually important because it forms the foundation for our discussion in this topic. Now let's go into some practical examples to identify independent and dependent variables. First, consider the age of a respondent and their blood pressure. So here, age is the independent variable denoted as X. Blood pressure is the dependent variable denoted as Y. So here the logical thinking is quite straightforward. As a person age increase, their blood pressure tend to increase as well. Next, think about the hours of study and their score on a statistics test. So definitely the number of study hours is the independent variable, X here, and the test score is the dependent variable. Why? Because in this case, the more hours the students study, the higher their test score is likely to be. Finally, let's consider the age of an operator and the number of units they produce. So what do you think? Which one will be the independent variable and which one is the dependent variable? Take a moment and think about it. So basically, regression analysis, it is a statistical technique used to utilize the relationship between two or more quantitative variables so that a dependent variable, also called as response or outcome variable, can be predicted from independent variable or known as explanatory variable, or sometimes we call it as predictor. So simple linear regression, it involves one independent variable only. So meaning that in simple linear regression, we examine the linear relationship between one dependent and one independent variable. While in multiple linear regression, we establish relationship that involve more than one independent variable, one regressive variable, meaning that we will have more than one x, the independent variable. Let's take a moment to revisit the concept of regression and see how it builds on what you might have learned in school. So you might remember we studying this in a basic form when we learned about the straight line in the school. And in that context, we deal with the straight line equation y equals to mx plus c, where the m is representing the gradient or slope and c is the y-intercept. Do you still remember? So the same thing we have here, but instead of we using y equals to mx plus c, we have this y equals to a plus bx. So a is a y-intercept, b represents the slope, so y is actually your dependent variable, so x is your independent variable. Now, let's explore the practical applications of regression analysis and how it can be used to describe and predict various phenomena. So, regression analysis, it helps us to create equations between different variables. So, this is useful, for making predictions about what might happen based on past or present data, or could be the future events. So for example, we can use regression to study how income can affect education. By analyzing data on income and education levels, we can predict how changes in income, increase or decrease, that might influence educational achievements. So this can help us understand trends and make better decisions in areas like could be policy and planning. So in short, regression is a powerful tool for turning data into meaningful insights. And of course, another use of regression analysis is to estimate parameters that describe the relationship between variables. So we can solve for these parameters actually by using several methods. We have ordinary least square method, OLS, maximum likelihood method, and also method of moment. And in many applications of regressions, of course, our goal is to predict the value of the response variable, the y. So for example, we might use regression to forecast sales, to predict sales for a specific promotion. So by creating a regression model, y equals to beta naught plus beta 1x. So we can estimate how future promotions, the x, the independent variable, might impact sales. So this could help the business plan more effectively, to allocate the resources more wisely and make better decisions. So in summary, this regression can allow us to make predictions that are valuable for planning and also strategy. Regression models can also be used for control purposes. This means we use them to manage or adjust certain variables to achieve desired outcomes. So when applying regression for control, it is important that the variables are causally related. For instance, consider using regression to increase the export of crude palm oil. So by controlling factors such as price, we can analyze how changes in price might affect the export levels. So by understanding these relationships, we can implement strategies to control and optimize the desired outcome. So that's the one of the uses of regression analysis. So here are a few examples of using regression for prediction. So firstly, to determine the volume of sales based on the expenditure spent for advertising, promotion, and sales incentives. So by understanding, how these factors could influence the sale, business can better allocate their budget to maximize their revenue. And the second one, to predict the demand for certain commodity based on the price and the price of other commodities. So this helps in forecasting how changes in pricing might affect the demand. And the last one is the house price prediction, to predict the price of house based on its size, location, number of bathroom, and number of bedroom. So this could allow the potential buyers and sellers, to deal with the property values more accurately. With a clear understanding of how regression works, let's now explore the concept of error and the key assumptions that ensure our model's accuracy. So in regression analysis, an error represents the difference between the observed value y and the value predicted, the predicted value by the regression model y hat. So mathematically, we can find the error as y minus y hat. So for our linear regression models to be reliable, the following four assumptions here about the error terms must be met. So the first one, the errors should be random and independent of each other. And the second one, the errors should have a mean of 0 and constant variance. This means that the errors are centered, around 0, and their spread is uniform, constant. And the third one is the errors should have the same variance across all level of independent variable. This is also called as homoscedasticity. And the fourth one, the errors should be identically, independently, and normally distributed. So this assumption, it helps us to make sure that our regression model is accurate and the results are valid. Let's see the basic of simple linear regression model. So in simple linear regression, the relationship between dependent variable y and the predictor variable x, or sometimes we call it as regressor, can be described by this equation. So this beta naught and beta 1 are our regression equation. So here, this is our random. So for example, for simple linear regression model, it could be to predict a sales of a product where we utilize the relationship between sales and factors such as the price of goods or demand to make our predictions. In multiple linear regression, the response or dependent variable y is related to multiple predictor variables, k regressors, through the following equation. So it could be y equals to beta naught plus beta 1 x1 plus beta 2 x2 up until beta k xk. So k is a number of regressors. It could be 3, 4, 5, or 10, or 15. So for example, to predict the length of a hospital stay of a surgical patient, we might consider various factors such as the severity of the operation or other relevant variables. So don't worry, we will go details into both simple linear regression and multiple linear regression in the coming chapters to explore their applications further. As we wrap up, it is important to remember that the main objective of regression analysis is to predict the value of one variable based on another, and secondly, to estimate the unknown parameters within the regression model. So thank you for watching this video, and I look forward to explore these concepts in more detailed explanation. Thank you.